Hello everyone and welcome to another SuncatByte. During this SuncatByte we're going to be covering your program for test cases, which is the wind chill program. So looking at the wind chill program, we have the spec here. So you're given a bunch of information, right? But basically what you need to do is calculate the wind chill based on this equation and the frostbite time based on this equation with some other criteria. As always, I'm going to assume you've already read this. But just looking at the test case portion of this, the first test case we're going to be looking at is from your test case doc, and it will be the one where the temp is negative 10 degrees and the wind speed is 40 degrees. In your program, please do remember that you want to make sure that the wind speed is greater than 5 miles per hour and less than 40 miles per hour. That's just also looking at your spec. We say that right here, right? Wind chill can only be calculated if the wind is blowing faster than 5 miles per hour and 40 degrees or colder. Okay, so just something to keep in mind. Now, using our wind speed equation, again, our wind chill equation, here, for degrees Fahrenheit, we're going to calculate the wind chill. So, given these parameters, wind chill is going to be equal to 35.74 plus 0.6215 times our temperature, in this case, which is minus 10, then minus 35.75 times V in the equation, which is our wind speed, to the 0.16 power, so 40 to 0.16, like that, and then plus 0.4275 times our temperature, which is minus 10, and then times, again, V to the 0.16, which is 42.16. So here we basically substitute our values in for T and V. Okay, so 35.74 plus 0.6215 here times T, which is minus 10, minus 35.75 times 40, which is V, to the 0.16 plus 0.4275 times minus 10, and then V, 40 to 0.16. So when we start doing all that math, we're going to get 35.74. Now I'm going to use a bunch of values of precision here just to keep my result as accurate as possible. So 35.74 minus 6.215 minus 35.75 times, and then this is that 40 to the 0.16. So it's times 0.1804 3866224 194838. Okay, so we have that, and then plus 0.4275 times a negative 10, right? And then times that same value, the 40 to 0.16, which is right here. So I'll just cut and paste. All right, so that is now going to give us 35.74 minus 6.215 minus 64.506 82175 149 654 585. And then minus 7.75828108432933245. Again, I do this just so I don't lose any. I want to make these results as accurate as possible for you guys. So when I do that, my result is going to be negative 42.69557, which is roughly going to be about, if we round to tenths, 42.7 degrees Fahrenheit. Just do F there. Okay, so 42.7 basically, right? Negative 42.7. There. So that's your result for the temp in this case. Now, what about the wind speed? One key, or time to frostbite. One key thing here that we asked you guys to do is there's a range of values for frostbite times that produce invalid calculations. Check your values using logic. For instance, if time to frostbite evaluates to a negative number, that can be a valid range. So what it's basically saying is there's some frostbite times that are no good. So what we want to look at here is what are those, and logically what would that be? And there's a hint in this actual diagram or this graph here for you. So one of the hints is you actually have a lower bound. You know that it has to be positive. Everything has to be greater than 0, so that's one piece of things, greater than 0. The other thing is when you start putting values in, you look at frostbite times, they start getting funny when you look over 30 minutes. And if you look at this graph here, notice it only does frostbite times for 30 minutes based on the color coding. That's actually going to be our upper bound. So that's what you want to use here. So make sure that you bound your frostbite times, or the ones that are, in other words, these are the times are only valid if they're greater than 0 and less than 30. Okay? I guess less than equal to 30. All right. So that's that. Now let's go and look at the calculation. So when I want to look at this calculation, what I want to do is break it up into pieces because it's kind of a complicated calculation, right? So if I look here back at my spec, here's my formula. Paste that over here. But what I'm going to do is I'm going to break it up. So I'm basically going to look at it, and I want to break it up into smaller parts. So I'm going to calculate this piece in here first. I'll end up calling that part 1. Then calculating based on the whole rest of this and calling it part 2. Then I'll come in here and do some stuff with this and calling it part 3. Then I'll bring this whole thing together and call it part 4. So basically what I want to do at the end of the day is say part 2 times part 4 to get my actual result. Okay? And if you think in this way, it might help you when you start coding it as well, right? Hint, hint. So part 1. I'm going to take part 1. I'm going to take that 40 times 8.0 divided by 5.0 times 0.667. So what I basically did here is I looked at this piece. 40, which is my temperature or wind speed, times 8 right there, divided by 5 there, and then I said times 0.667 here. Okay, so if I do that, I'm going to get, for that basically is part 1, 42.688, 42. All right, so done. Now I want to say part 2. So what I'm going to do is basically take what I had for part 1, which is that 42.688, right? All of this stuff in here, and I'm going to add the 4.8 to it from here, and then I'm going to multiply by this negative 24.5. Okay, so now, oh, and then add in the 211 as well here. So what I basically end up with is 42.688 plus 4.8 times minus minus 24.5, and then that whole thing plus 211.0. Okay, so 42.688 plus 4.8 times minus 24.5 plus 211.0, that's going to give me 947.544. So that represents this whole side of the equation. That calculates to 947.544. Now, part 3, looking at the other side and breaking things down. That's going to be equal to, our temperature is minus 10, so we're going to start here, minus 10 minus 32 times 5 divided by 9. Okay, so minus 10 minus 32 times 5.0 times 5.0 divided by 9.0 gives us negative 42.0 times 5.0 divided by 9.0. So what does that give us? It gives us negative 23.33 repeating. Okay, so now we've got all of this. We now need to take negative 4.8 minus that and then raise it to the minus 1.668 power. That's going to give us part 4. So part 4 will be that negative 4.8 minus, and then a minus 23.333 repeating, right? So we end up adding that, and then we're going to raise that whole thing to the negative 1.668 power. So that's going to actually be 18.533 repeating to the negative 1.668 power, and that gives us this decimal 0.076745602605128. 0.076745602605128. Now we just want to take part 4 and part 2 and multiply them, right? So this was part 2, so we're essentially taking this side of the equation, part 2, which is 947.544, multiplying it by part 4, which is this side, 0.0077645, and so forth. And we get, when we multiply those two together, I'll go ahead and do it this way. This times this will give us, oh man, we don't want that, 7.271983524. 7.271983527 minutes, or roughly in the program, it's okay to just do casting or whatever you need to do in this function and return a minute value, an integer value. So in this case, we're talking 7 minutes. And that'll be it. So that's the key thing for your test case, is you do have 2 other test cases to finish in this set of test cases. Remember though, you do want to make sure that the wind speeds fall in this range. And then in your programming in here, you want to have that frostbite time be bound. So in your program, if your frostbite time is less than 0 or is greater than 30, that's a problem. It's not just say, you can just say that there's no frostbite danger. Well, that's it. And if you have any questions, comments, or concerns on this, please do let me know. I will talk to you all soon. Take care. Bye.